Okay, we're going to start a new program. And we are moving on to San Francisco, California, and we will use the LiDAR data. First, we will build skills in explore the properties and statistics of an LAS dataset, and we will conduct interactive surface analysis, identify classes, classify terms, and generate elevation, slope, aspect, and contour. Visualize an LAS dataset in 3D and create a layout of an LAS dataset. And we will need publisher or administrator role in ArcGIS organization, ArcGIS Pro estimated time. I think we will do hopefully 1 hour. Okay, scenario is one of the first tasks of a GIS department using LiDAR data is to understand the functions within the ArcGIS Pro interface. We have been tasked with creating an exercise that provides information about the Appearance tab. In addition to the Appearance tab, we are to provide instructions about deriving pertinent statistic and visualization of the LAS dataset in 3D and create a 3D layout. Deliverables. The following deliverables are recommended: a layout of the San Francisco dataset with an explanation of the study area and a written report explaining basic LiDAR information and statistics with visual examples of ArcGIS Pro functions and 3D scene to view the LiDAR data in 3 dimensions and 3D layout to export as a printable PDF. So I already have the data, so I can just start with a blank and save it, and I will just say SF desktop and here. Oh, go back and SF. And then click OK. And once I have everything, and then I will add a new map. Okay, then I will connect to folders. And click OK. Once I have the folders, and the only thing it will be getting the data. So analysis, go to tools, and we will have extract package. Extract package, then input package. It will be in my downloads, and San Francisco data, and then desktop, this, and click OK, click run. Once we have the data the same way, we will see the file, and we click run. We have now extracted package and the contents of the San Francisco data package to the data folder here. To access the data, we must set up the project in the catalog pane. In the catalog pane, we can access all the project components, including all the maps that we create. In the catalog pane, we right click on the folder and add folder connection, which I already did, and add the folder. Data folder where we extracted things. So San Francisco data. We have the tool. Databases here. And Baltimore data. We have a San Francisco. In user data folder, we will see one file. Okay. And I should add nothing is there. Refresh. Use USA3 layer file, not this one. Actually, I don't need those data. But I have nothing out on the map, and then I don't know the coordinate system. So let's see if there are another option to do it. I'm gonna extract it again and see. San Francisco study area. Let me refresh everything here. I already add the photo connection. Right click on it and fresh. Okay. SF. San Francisco, okay. Alright, it doesn't like to work here. Go to downloads. I'm going to extract the folder and copy it. Just cut San Francisco. Right click on it and zip. Extract files. Click OK. Right click on it. Cut. Go back to my folder. Desktop and go to my folder. Down at the bottom, I'm going to paste it here. Paste. Okay, then let's refresh it again. Now I should have a San Francisco data. Okay, San Francisco data. And the P13. Okay, SF data. SF, I don't think that was there. Now finally I can add to current map. Once I have it, and then and inside the folder we have a folder, P folder. Okay, we should have a file of ARRA CA San Francisco Coast 2010 something something XML. That's the metadata for an LAS file. That's all we need. Other than that, we do not need anything. So let's look at the spatial reference. Finally, we can look at the spatial reference. Go to properties and go to source and spatial reference. It is the NID 1983 UTN zone 10 north. Click OK. In the next session, we will set the output coordinate system for geoprocessing to the same coordinate system as the data frame or first layer, because this projected coordinate system most accurately preserves measurements within the localized area. And now I'm going to environment settings. Current already is San Francisco, the same as study area. San Francisco, okay, NID 1983, UTN 10 north. Extent, it will be San Francisco study area. The create a process summary that we're going to do is a process summary lists the steps we need to do for the analysis. It is important because it will allow us to or others to reproduce the work. We suggest using a simple text document for the process summary and keep adding to it as we do the work to avoid forgetting any steps. The next list shows an example of the first few entries in a process summary. We will extract the project package, produce a map of San Francisco, and create an LASD dataset, examine the LiDAR data. The analysis, once we have obtained the data and set the environments, we are ready to begin the analysis and to complete the data displays. We need to adjust the problem for this module. We have been asked to examine an LASD dataset, create a 3D scene, and publish the scene. Last time we didn't publish, we just create a map. So I think here we just say create a map. Deliverable 1 is a layout of the San Francisco LAS dataset with an explanation of the study area. We will start in the analysis, produce a basic San Francisco map, create a LAS data first, create LAS dataset. Oh, no. Okay. So once I have this, I have to look at the input file, and we will look at the range of the elevation. We will, using the imagery with label base map in the contents pane, and turning northwest quadrant LASD on and off, and see what is the 2 quadrant study area and what structures can easily be identified. And we can also do the point spacing, looking at the point spacing and how does the point spacing determines the resolution of derived gridded products, and how would the horizontal resolution of point spacing of a data affect the resolution of ground surface features. And we have to write a brief paragraph describing the data, including the number of points, vertical units, spatial reference, classification codes, and return values. Okay. And then we will do a written report explaining basic LiDAR information and statistics with visual examples of ArcGIS Pro functions. And the appearance tab, point symbol, and I will deal with the symbol and classification or other purpose points in the data set. And how many returns are there and what do they mean? Appearance tab, we will do the surface symbology and describe how the data looks using this data structure and what do the slope and aspect surface show. Appearance tab, using the line symbology and what do contours represent. Appearance tab, full resolution appearance tab, LAS points filter appearance tab, combine functions. And then we can do a little bit more, and we will convert a map to the scene and add height to the buildings, extrude buildings. So, and finally the PDF. And first I have to find the file. Let's see, where's the file? User data. There. And output. Okay. Let's just use. Everything looks good. Let's review a little bit more. Input file that I did went in to get the file. And then output, we have northwest quadrant LASD. I don't think I'm gonna change the name. And coordinate system, yeah, that's fine. And no LA, okay, we have to check compute statistics and store relative path and click run. Once it's done, we will look at the range of elevation. Alright, just wait a little bit. I'm gonna. Okay, elevation, we have it. Okay, of course, it's a lot different now. we can see the elevation. Yep, the elevation now we have is 263.98 to negative 35.28. Okay, that's not that bad. Okay, and then we have, let's see, we already find the range, and let's see what is next. Okay. Range elevation, let's look again, 263.98, negative 35.28. And then let's look at the property spatial reference, and let's open this. Okay, we have, okay, the projection is fine, and we will have data, and let's look at the filter. Yeah, everything. We have a water. That's cool. And first of many, return an elevation, and source, general. Okay, let me let me copy its name. Copy, and going to do Python. So I'm going to import ArcPy first. Okay. And we will input ArcPy. Dot describe. This. Okay, put the file name and dot point spacing. Okay, which is point 0.675000160933 something something. Okay. And and we have everything. The vertical units, spatial reference, classification codes, and return values. Everything is there. And now we're going to do is appearance tab to do the point symbology. What classification are the purples? Purple. Purple. Let's click appearance and purple. Let's see symbology. It didn't have a purple. Purple points in the data set. Purple. Then it will be water, okay? Because let's see if they have a water somewhere. It's not really purple. Yeah. Looking at the elevation, I don't see that. Okay, and we will be able to see the return 1 of 1. So the dots we can see 1 of 1. Compare, play around with the let's see, not this one. 1 of 1. Okay, that's the return 1 of 1. And we can see different returns, and let's see. Do we have an open attribute table? Nope. Okay. Data percentage, we have a 13. Let's change it. Right now, I think it's all points. All points. 13%. That's weird. Okay. Appearance tab using line symbology. Okay, we can do symbology. Contour. Let's see the contour. It's generating. And I will generate full resolution. And appearance tab, LIS point filters, appearance tab combine functions. There. So that's the contour. That's cool. we have to write everything about it. So line symbology, and we could also do appearance. Okay, now I'm going to do the full 2, 5, 1, 2, 3, 4, 5. Okay, let it render a little bit and we will see the difference. And this time we will just do elevation, symbology. It's rendering. We're going to give us a little time, and then I will do buildings. Elevation. Just wait, and it will be a lot different. Cool. And these are the combination. And if I don't want contour, can I get rid of contour just by clicking it again? Okay, if I don't want contour, then I do elevation. There, so wow, we can see it's a lot clearer, okay? This is 2D. Now we're done with the 2D. We did combination functions, and we could do other points, ground, and we can change a little bit. Now I'm going to go view and convert to 3D. Now we have 3D, and I totally forgot how do I change this thing back to I totally forgot to change this thing. Okay, San Francisco Bay and everything. Jacket here, okay. Okay, this is 3D and the buildings, okay, buildings. I'm going to put buildings to 3D, and I forgot if I need to calculate for a still rendering. Okay. And how do I do Z value? The building, we should have a Z value. Oh, I forgot to add it. We have to add the height to the building, okay? Let me do the 2D first, and we have to run a tool. So this tool is LAS point statistics. LAS point statistics. Point statistics as by area. input, and input polygons will be our buildings. And we want maximum Z. Click run. Buildings, and that should be it. And let me double check. Right click on it and open attribute table. Then we should have the Z value. Okay, it's loading. Once we have the Z value, and then I will be back in the 3D mode and show our building. Where is the Z value? Cannot see. Okay, this time we do have a Z max and Z minimum. That's cool. Z max, Z minimum. So many buildings. Close it out. And let me back to my 3D and let's see. It should be updated as well. Open attribute table. Okay. Okay, Z maximum, Z minimum. I forgot previously if I added. Okay. Let me double check. If not, I have to rerun it. Our catalog pane. Okay. Layers. Let's add the buildings again. Okay, right click on it and go to open attribute table. If I don't see the Z, if I see the Z, oh, then I didn't calculate it. Let's see again. I'm gonna remove this. Remove, okay. And I'm going to bring the tool back on again. By area. And input LAS dataset. And we will use the ARRA San Francisco Coast 2010 and 10 as LASD. And input, of course, it will be building blocks, and we want maximum Z and click run. Okay, once it's done, let's see, right click on it again, open attribute table, let it show up. Showed up. Object. I think maybe it has a Z max, so that's why it's not calculating. That's very interesting. Okay. That's the Z. Even we do not have to do anything. Okay, let's back to the 3D then. Okay, we have the building, and I'm going to this is 3D. Okay, 3D that, let's see, symbology, and we are doing elevation, yeah, for sure. And I'm going to redo 10. Okay, and do 9 again. 9. Okay, let it render. Okay, zooming in, zoom out. Oh, it's gonna back. It turned back to 2D. appearance, symbology, elevation. I want all the points. I'm going to delete this. Okay. Remove. Okay, when I turn this into all points. Why? I forgot what's going on. Okay. Appearance. There. It's elevation. Okay. Then my building. Symbology. I could do classification. Or unique values. Let me just do classification. Graduate colors. This doesn't make sense. Let me see what kind of building they have. Okay, longitude, latitude, and G something. Height. Oh, area, number, fact. Okay. Code. If I use code, I can do categorical data. Okay. Alright, let's look at the code. Appearance. Graduate colors. Not working. Oh, it worked. Why are you so slow? Okay, this will be the maximum Z value. There. Cool. Then what are those points? Okay, San Francisco. San Francisco. I'm going to do something like this way. Tilt it a little bit more. Okay. There. What happened to the building? Symbology? Okay, now finally. It's thinking. Okay. Da da da. Let me use different color. I remember there was some name, number of faces. No, 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 no. Maximum height, longitude, latitude, number of facets. Okay, I'm going to do 20 different colors, and we'll use a color ramp. Okay. Show all. Yay, nice. Okay. Okay. And this is the 3D for San Francisco, and I'm gonna turn it a little bit. And very nice, okay. And the points is a little bit different now. Let's see, what can I do with those points? It's all points, symbology, class. Yeah, I want to do class. That's what they want us to do as well. And turning around as well. Just like this, okay. We do class and classification symbol. Make it bigger, too big, smaller. Okay, this looks fine. But where are those others? Okay, let me right click on it and go to property. Can I keep the cache 5 minutes? Elevation. Okay, elevation I'm going to do a little taller. 5, still low. Let it grow. 6, 7, 8, 9, 10. Click OK. Ten is too much. Right click on it, go to property. Let's do 5. Click OK. Why the unsigned value? Let me see. I think something wrong with the georeferencing or something. It's just so slow. I thought the data would be a lot better. Okay. It has ray. Yep, it does have ray. Ray away, and 5 is still too much. Let's do 3. I think 3 is good. It's just some of the color, it doesn't show that nice. Unsigned value. Symbology. Let's change the color ramp, okay. I don't like the green. We will have to brew to the red. Okay. The cyan, I don't like neither. I want the blue. These. Okay, that's fine. But still, weird color. I want something blue on left hand side. Let's look a little bit more. I want blue on left hand side. Kind of like this flip around. Let's do this then. Okay, this looks a lot better. And I'm going to do layout now. Let's go to insert, new layout, and we will do portrait. And I will say San Francisco Lida. And add the cool, it's beautiful. Maybe I could let it zoom in a little bit, but I think, yeah, I should because I have a lot of water body here. What happened to the building? Let me do dynamic text and move it out. Okay. Now building is here. I'm going to activate the map. Okay. It's like this is being cut. Maybe my extent, I didn't set it well. I shouldn't have the extent. Let's see. Environmental settings. Go to analysis and environmental settings. And I don't want okay, click OK. And I think I'm done because I'm going to put some, cut it from here. And then move it out a little bit. Activate. Okay. Save. And layout. I'm going to add title and north arrow. Insert north arrow. Interesting. And I'm going to add legend. Wow. I might not want the that's weird. Okay, I'm going to break it down. So, convert it to graphics, right click on it. Okay, and then ungroup them. And I'm going to delete this. And ungroup them. And I'm going to delete these. And select these. Right click on it. Right click on it and group. Group. Alright. Put it here. Now I will add, I don't want the road and everything. Oh, I don't need that huge one. Okay. Okay. Then I could, there cannot be a scale bar. And what else I'm going to put that there? Add a title. Okay, San Francisco. Okay, I have a San Francisco LiDAR 3D. The same way I will make it format bold. Okay, I will make it 33. Okay. Alright, there. I can just put the source here and then datum, name, and spatial reference. Yeah. That's for 2D. Okay. Move a little here. That's it. I will think about what I'm gonna add because here the space and the source. Okay. Very good. Next time we will move to location of solar panels. That's will be very interesting project, and I hope you will enjoy it. So this one I don't enjoy it that much because basically it just making a visualization, and it's not it is not that quite useful in terms of maybe solving a problem. It just showing something. Okay, and then I'm going to export my map. I didn't do for the San Francisco 3D. The first one is Baltimore. Let me open my Baltimore and export one. Okay. And for the solar panel, I don't think it will take that much time. And we will do is that still using LiDAR data, but I think the LiDAR data there, it's more meaningful because we will solve a problem. We will know, oh, where are you going to put solar panel, and the tree height for the last chapter. I don't know whether it's that quite useful because I'm not doing ecology. So, and this one I'm going to export it. And then we can compare. I did use elevation points. That's odd. Okay. Hmm. Share. And now I'm going to say Baltimore. LiDAR 3D. There. So, alright, thank you. We will move to location of solar panel next time. Bye.